Here's what the lab looks like if you set up your 10 milliliters of monoprotic acid and then you add the carbonate. You will start seeing the reaction happen. You will see bubbles, you will see fizzing. And I always have my students answer the question, I think it's number 5 in the pre-lab, how much should you expect magnesium carbonate to react or calcium carbonate to react if we have exactly 10 milliliters of approximately 1 molar strong acid. So they actually have to do a calculation. They find out if it's exactly 1 molar, then they should have about half a gram of either magnesium carbonate or calcium carbonate. And they add, and eventually the reaction stops. Some students want to weigh this before and weigh this after. That's usually the best procedure. Others of them come up with some kind of random ways of doing it. Students are also not really good at knowing what is about a half a gram. I like the fact that many of them will be very precise with their measurement, but that also compromises the time factor. So if you want them to work fast, then the precision is probably going to be less, and that's fine. This lab does not involve any indicators. It doesn't involve any pH measurement. We just go for the reaction until all of the acid has reacted. Remeasure the mass of the container. Some students want to pour out 1 gram and go from there, and I say, well, what if you need more than 1 gram? More measurements that you make, more error you introduce. So using the bottle and just adding the amount that you need until the reaction stops is usually the best procedure. One thing that is important in this lab, as with any lab where students are identifying unknowns, they have to tell me what is the letter or number of their unknown. So if they just say, well, my unknown was magnesium carbonate, I'll say, great, what letter? Another factor that comes into grading this lab is I don't quite care so much if they are exactly right with their unknown, but the 2 things I'm looking for, number 1, did they determine whether it was soluble or not? Magnesium calcium carbonate are both insoluble, sodium and potassium carbonate are both soluble. So that's one of the things. If they say, oh, I think letter B is magnesium carbonate and it's actually sodium carbonate, I'm going to say, well, did you check the solubility? That doesn't make sense. And then, as with most labs, I want their values of the molar mass calculation to be within 10% of the actual value. And rather than them knowing that the actual molar mass is exactly correct, obviously you could be very close to both sodium carbonate and calcium carbonate. They're very close in molar mass. Then the solubility becomes the important factor. And you could theoretically be halfway between the molar mass of magnesium carbonate and calcium carbonate and be within 10% of both. So then I ask them, well, if you can't determine for sure, what else might you do if you wanted to determine your unknown's identity?